All right. Really think that we know mostly enough about how to create a class to polish off this chapter. But they go on a little bit more. Some of this stuff we already know. What is a local variable? It's one that's not part of the class, it's part of the method. Like it's declared in main. Right? In main you do int x is equal to 3 or whatever. That's a local variable. It's local to main. That means that you can't access it from any other function unless you pass it in. Now an instance variable is one that's defined inside the class, so it can be accessed by any method, any instance method in the class. So we had class book, right? And it had some members like the title of the book, right? And then we had another class, which was our app, class app. And it had public static void main in it. If we declare a variable here, string book title equals, Harry Potter 1 and the Goblet of Fire, whatever, then this variable here is only accessible inside the main function, the main method. If we have another one down here, whatever the function is called, it can't get a hold of that unless we pass it in. If this variable needs to be accessible to both this one and this one, we have two alternatives. One is we could pass it in, right? And then when we call the something function, we could pass it in. That'd be one way. The other thing we could do is we could make it a member of the class. I could take that string and make it a member of the class. And so I would not define it inside main. I would define it inside a class. Now, since main is declared as static, public static void, then that means that all the class members it tries to access also have to be declared as static. And all the methods it accesses in the same class have to be declared as static. So whatever. But now, system.out.println, we could print out the book title because book title is accessible to both of these functions. So int x, this is a local variable. It's only accessible inside main. Its scope is between those two things. Book title is an instance member. It's a member of the class. So it's accessible to any of the pieces of code between there and there. Now this guy here is only accessible inside of these things, but since it's not declared as private, you could also access it as a member from outside. So like if I create a new book, book B1 is equal to new book, and then I want to set that title equal to something, b.title, Jaws, my favorite book from the 70s. There we go, right? We were able to get a hold of that variable because it's a member of the class. It's an instance variable. If we marked it as private, then suddenly this would be an error. We would no longer be able to access it. So I'm going to say that this is a public instance variable. So we can access it here. This one, int x, is a local variable. This is another class member. It's a class variable because it's declared as static, not an instance. You don't have to create an instance of the app class in order to access it. We will hit some of those topics again. So a local variable is declared within a method. It's called local because it can only be used inside that method. Do local variables have default values? No, they don't. So you have to give them a value. So for example, this is a mistake. This is an error. Int I. Well, we created a variable, but we didn't initialize it. Saying int I is equal to 0. Now we have a good piece of data in it. Local variables persist only for the duration of the method, or the for loop in which the local variable is defined. The next time the method is executed, the local variable resets back to its initial value. So if I came here and I create, see, I have x is equal to, and then later on, I do x is equal, x plus plus or something like that down underneath here. the next time main is run, x will equal 0 again. It does not maintain its last value. Now, for you C++ programmers, everybody else close your ears. You had a keyword called static. Static meant that this variable maintained its value even between calls to that function. Now, it doesn't make sense for it to be inside main, right? But if I went down here and I created a static variable, every time we went back in here, we would increment y by 1. It would not reset back to 0. Okay, you see, you Java programmers can now reopen your ears. There is no static keyword in that context in this language. They repurpose the word to mean something else. So the return statement allows you to pass a value back. So getAge will return a value. Now, it could be a calculated value, could be a variable that's defined within getAge, or it could be a variable that's part of the mouse2 class. In this case, prefixing that variable name with this dot means that it is a member of the mouse class. It's not a local variable. It's also not a parameter. So, you can also declare a method as void, meaning it doesn't have to return anything. You can put an empty return statement there. Works great, however, Netbeans flags it as a warning, which is stupid. It just does what you expect. It terminates the method, causes control to go back to the calling module. So if I do this, if I had a return statement here, because this is declared as void, I could not return anything back. So when I called something from up here, it would jump down here, it would start executing this code, it would hit the return statement and jump back up. Except Netbeans is picky, it would not let it compile. It would say that this is unreachable code, and that's an error. But if we had this in an if statement of some kind, right? If y is equal to 0, then return, else, do something else. Right. Okay, so it would run that. It would print the book title out. Is y equal to 0? Sure is. So it would return. It would not do this part. But if it did, then once it hit the closing brace, it would return anyways. So if it's a void function, if it's a void method, then the return is optional. You don't have to put it there. But if it's declared as returning something like an int or a double or a float or a book title or something, then you have to have a return statement, and it has to return a compatible piece of data. So like if something or something function is supposed to return an int, it better return an int. Okay, this is really stupid code, right? Because it just returns the same thing no matter what. Well, not necessarily, but anyways. So, hopefully you get the idea. Return causes it to bail out at that point. If this statement gets executed, it's not going to do any more of this stuff. This piece of data has to match this. So if I declared y as a double, but the function, if the method is declared as int, that would not work in this language. C++ is so loosey-goosey, it'd go ahead and do the conversion for you and return an int. Alrighty, software engineering observation. Why don't we just throw a giant paragraph of text here? Real-world programmers are often asked to maintain, to fix and improve other people's code. You can get a job as a maintenance programmer, meaning that your job is full-time to fix bugs in other people's code. That's how I started, in one job. In doing that, they often find themselves having to examine the loops to figure out what's going on. It's important that the loop termination conditions are clear. If you put return statements in the middle of a loop, and then there's a whole bunch of code around it, like 100 lines before it and 100 lines after it, it's real hard for somebody else to come up to your code and figure out how the loop is working. So if you use a return statement inside a loop, the return statement gives you a loop termination condition that's not in one of the two standard places, meaning the loop heading. right? So if you have a while x equals 10, or while x less than 10, but later on inside the loop you have if x equals 5, return, well, then there's actually more than one way out of the loop, right? Once it counts up to 10, it's going to quit, but also if it happens to equal 5, it's going to quit. So there are two loop termination conditions. So it can make things a little more difficult to follow if you have return statements in the middle of the loop. The same is actually true of a break statement. You just have to kind of try to write your code in such a way that it's easy to figure out how the loop is terminating. Now, if you're going to have a break statement, but it's called a while true loop, then you know there's going to be a break or a return. That kind of makes it clear, right? But if you stick a break inside of a for loop, then it's not immediately obvious to somebody who's scrolling up and down to your code that there's more than one way for the loop to exit. So use restraint when using return statements or breaks. If inserting a return statement improves the clarity, go for it. But if you do it just because it makes it easier to program, but it doesn't make it easy to read, don't insert. So Java uses pass by value to pass arguments to methods. And this feels like another lecture that I ought to sit there and draw stuff on the board for 20 minutes. And I don't feel like doing that right now. But pass by value means that the value is copied into it. So here in my code, if I declare a parameter and I pass a value into it, a variable into it, the value of x gets copied into foo. And it doesn't matter if I change foo, x stays the same. Because it's being passed by value. It's being passed by copies, just like I give you a photocopy of it. If you crumple up the photocopy and write something else on it, I still have the original. So even if we had foo is equal to 1,000,000 down here before it had hit the return statement, x stays the same value. However, there is the other mechanism that like C++ and C# supports, which is known as pass by reference. Java doesn't have pass by reference, but it kind of looks like it does, and I'll show you what I mean. I'm going to write something public static void print something, right? It's going to print a book, right, because I have a book class. And inside here, I'm going to say, book.title is equal to erased. I'm erasing the title of the book before I print it out, right? For some stupid reason, I do this. Okay, so down in here, if I create a book, and then I call the print something class, right? So I'm going to make a book. Book B is equal to new book. And then I'm going to give the, I already had that. Book B2. And then I'm going to set the title of it, B2 dot, another Twilight. And then I call print something, and I pass B2 into it. This passes the value of B2, which is a memory address. It's a pointer into that thing. But since that's a memory address, if we start accessing the members of it, we actually are changing the data. It's like I give you my home address. You can go to my home address and you can break all my windows. Even though the home address I gave you was a photocopy, right? I photocopied a sheet of paper that had my home address, but you were able to go to my house and actually make changes to it. It was passed by value, but it kind of acted like it was being passed by reference because this was actually able to change it. Hope that makes sense. Remember that if you pass in an object, if the variable type is a reference type, if it's of a type class, then you can change the members of it like that. You can actually get to the members and change it because you have the address of it. What you can't do is create a brand new object and pass it back. Right, if I do this, B is equal to new book, and then I create a new book to pass back. B is equal to, B.title is equal to programming with Java. When I get back here and I print out B2, it's not going to say that the title is equal to programming with Java. It's going to say that the title is equal to erased. The reason why is because we have the address there, so we're able to access the members of it. But B is still a copy of something, and even though we change it, the original address is down here and it doesn't get changed. I hope that's not too subtle a point. Read the chapter real carefully about it. All right, so argument passing. An argument and its associated parameter are usually, or often, of the same name, but that doesn't mean that they're the same variable. They don't have to use the same name. The only requirement is that they are the same type. So, when we're calling the .grow method of our mouse class, it doesn't matter what the parameter name is. We just have to pass in an int. We could have stored our int inside a variable called num, or a variable called Fred, or a variable called age, or whatever. The method will accept it just as well. All right, specialized methods, accessors, which we've been calling getters. These are the ones that get the private instance variables. So, if I have a private instance variable called age, like if we're inside my class, and I do int age inside my class, but I declare private, then the only way that the main code or the client code or whatever can access it is if we provide an accessor method. Same for the setter. In order to set this % growth rate, if % growth rate had been declared as private, then the main code would not be able to access it directly. So if this was declared as, private, double % growth rate, main would not be able to change it. So we'd have to give it a public method so that it could change it. And we've done that a couple of times. We created a class, it had a couple of members in it, and we provided some getters and setters. Mutators are the setters, accessors are the getters. Boolean methods. You can have methods that return any type. I don't know why we're making a big deal out of the fact that you can have a Boolean method, because that's just another type. It's one that returns true or false. By convention, you call it is. So like if you have a mouse class, class mouse, and it's got an age variable. How many days old is it? You could write a Boolean method called isOld, and it would return true if the mouse was old. Now I don't know how long mice live, but I'm going to do if age is greater than 1,000, then it's old. Now I structured that kind of wordy. I'm going to show you a cleaner way of writing that. It's fine. You can read what it does, right? I'm going to make another one called isYoung. Public isYoung. And I'm just going to do this. Return, parentheses, age less than 10. Anything that's younger than 10 days old is young. Right. This works just as well. Why? Because this evaluates the true or false, and if it's true, it's going to return a true. If it's false, it's going to return a false. So we could have replaced this code here with return age greater than 1,000. That means the same thing as this if-else statement. However you like wording it is fine. This is the way that most programmers, once introduced to it, would do it. But if it makes the code easier for you to read, to do it that way, feel free. So why do you do that? So that down in main, after you create your mouse, whatever, mouse m equals, new mouse, and you set its age equal to something, then you can do this. If m dot is old, then you do something. Print something, whatever. Print. Time to retire, Mr. Mouse. Right, because he's old. Whatever. Like that. So it's returning a Boolean variable. Whoopsie, what did I do wrong? That definition is not correct. Ignoring the fact that it's a method, even if it was just a pure function in another programming language like Python, what's wrong with that?
Doesn't return a valid value for the
Right, it doesn't have a return type at all. So it doesn't know what to return.
And the same would apply down below it.
Yep, that one's broken too. There we go. Now that's better code. Every function except a constructor needs to have a return type. The constructor is the only kind of method that doesn't have a return type. And Netbeans would flag that as an error. And by the way, if you're stuck on something, oh no, I'll get to that if we load up Netbeans. All right, I think we're at the end of the chapter. Which of the following is a data item in the class? Well, if it's a data item, is it that? That's just a keyword. That's a modifier that describes the data item. Is it that? No, that's a method. It's a function. It may use a data item, but it's not it. Instance variable? Yes, that's a data item in the class. All right, which one creates a new object? Yeah, well, I just used the word new when I asked the question, but yeah, the new is the one that creates the object. It calls the constructor. Whether you see a constructor or not, every class has a constructor. Given this method call, what is the thing called that's inside the parentheses? All right, so when we're calling the assign speed method and we're passing something in, what is that called?
An argument.
It's an argument. Now, to make it tricky, one of the answers should be a parameter. Then, some people would choose parameter. But it's not a parameter. The parameter is the variable that catches the argument. The argument is what's passed into it. It's funny that it has two different names. Some textbooks would call the definition of it the formal argument and the actual argument, but forget that. I think that's the C++ textbook that talks about that. Let's take a look at my little samples here. Where did I have a function written? Here. This is a parameter. And then when I call something, that's the argument.
So arguments, so parameters have return types in front of them, while arguments do not.
Yeah, this is returning something and I'm not capturing the return value. That's probably dumb, but it's legal. I can go ahead and call something and ignore the return value. But probably, if I'm going to go to the trouble of returning something, I probably want something that would capture the value. So let's add some comments. Argument is the value passed into the function, the method. Parameter is the variable that receives that value. Every method must have a return type except a constructor. The return type can be void, meaning that it doesn't return a value. If the return type is void, the method does not have to have a return statement. If the return type is not void, it does have to return a value. And constructors don't return anything because they don't have a return type. All right, these little quizzes at the end of the PowerPoints are pretty pathetic, like only 3 questions. Well, maybe here's a 5th one.
The 4th one, you mean?
A 4th one, yeah. What's the formal name for a method like setAge that sets the value? We've been calling it a setter, but which one is its official fancy name? The accessor is the getter.
Mutator?
Yep, so it's a mutator. All right. I think we're back done with chapter 6 again. All right, the wrapper classes. This is actually for chapter 5. The wrapper classes are when you need a class to manipulate a primitive data type. In this language, unlike some, you have a distinction. In some languages, absolutely everything is a class. Ints are classes, and longs are classes, and floats are classes, and stuff like that. But in Java, these are just primitive data types. They have an address stored in them that points to an integer or a float or a double or whatever. But then there are some classes that provide helper functions to help you use this kind of stuff. So for example, if you have a value stored in a double, you may need to do things like convert it to a string, in which case you use the wrapper class. I'm going to go ahead and load up Netbeans to make sure that I give you actual examples that actually work. So just like Iron Man is Tony Stark, but he's got his iron power suit, which makes him more powerful, the wrapper classes wrap around the primitive data type to give you extra functionality.
I mean, you watched the second movie. He says it's a prosthesis.
Oh, no, actually, I haven't seen it.
Iron Man 2?
Nope, I'm lame.
Oh.
Why haven't I seen it? I don't know. Alrighty.
He calls it a high-tech prosthesis.
Cool. So it looks like we're on cue. All right, so I have a number stored in a string. String number is equal to 123.456. I want that value in a double so I can do math with it. And why'd you store it in a string, you dummy? Well, you can't always just call .next double and have the Java library convert it to a double for you. If you're getting data from a socket, off the internet, if somebody's filling in a form, it's going to come to you as a string, and it'll be up to you to convert it. In which case you have to use parse double. And so you would do something like this. Double, and then whatever you wanted to call your variable, I'm just going to call it D, is equal to double dot parse double, and I would pass that string in. You could even create a piece of data of type double with a capital D with the wrapper class. Let's see if that gives us any cool options. Double is the wrapper class. Double with a lowercase d is the primitive data type. A primitive data type is just all the different number types, ints, floats, longs, and whatever, as well as Boolean. Okay, so I'm going to make a variable of type double. Double, I don't know what to call it, dd, is equal to new double, and I'm going to pass in that number that I just created here. All right. So this is a primitive data type. It doesn't have any functions attached to it. It doesn't have any methods. If I type d dot, it doesn't pop up a list of functions. There's no members attached to it. It's primitive data. However, dd here is a variable of type reference, of type double, so it's a reference variable. I can type dd dot, and it lists a whole bunch of functions. And some of these I don't even know why we would use.
For example,
Like, what is byte value? Let's find out. I'm going to print out the byte value here. System.out.println dd.byte value. I guess I could look at the help file, huh? All right, the byte value is 123. It has converted it to a byte. Same thing as casting, I guess. If I'd done, you know, byte b equals parentheses byte, into parentheses value. So that's kind of the same thing as doing this. Byte b is equal to parentheses byte, you know, d, like that. Converting d to a byte. We've seen casting in the past. If we printed this out, it would equal the same thing as dd dot byte value. And so there's other ones. dd dot, if I wanted to convert it to a float, sure, it can do that. If I want to convert it here, here's some funky ones, like infinite or is nan. I'm not sure how to create a variable that's not a number. What if I make this garbage? So instead of being 123.456, what if I throw some letters in? Shouldn't even come.
Well, just run it and see what happens.
Yeah, I got something funny going on here. 3 build errors. Not a statement.
Well,
Oh, right there, right there. That's not a statement. That's true enough. Okay. And it blows up with an exception. We could use exception handling. Just like if you took Python, we did try except in order to catch errors. But that didn't get us a not a number value. So that little method that we saw, dd dot not a number. Oh well. Anyways, you get the idea. There's a way to compare. You asking a question or just, yeah.
Could you scroll quick just a second?
Scroll up or down.
Oh, real quick. Thanks.
I don't have anything above this.
the type of exception it generated was a number format exception.
Right, right. To fix it, I'm going to have to change this.
And it said for input string. Why does it say that?
Because this is not a valid number. It doesn't know how to convert that to a number you could do math on.
Well, what's the difference between that and input mismatch exception?
Same thing. In a different context. Input mismatch is what happens when you call next double, right? So the scanner class will return input mismatch, but parse double returns number.format exception.
And then for input string.
Yeah, I'm not seeing that error. Where do you see
To
it?
the right of number format exception.
Oh. Okay, it's just telling me that this is the data that was wrong, right? That's the data that it could not convert. And it's funny that it's telling us the name of methods that we don't see, but that's okay. I don't know what sun.misc.floating-point decimal, you know, this is a package called sun.misc, and this is an object, a class definition inside that. It's interesting to me. I hadn't noticed that before. So that's a good question. This is telling us what the data was that it failed to convert, and this is telling us exactly what was wrong, that it was a number format exception. So I'm going to fix this so I don't get that error. Did you get what you needed?
Yeah, I'm just trying to catch up on.
Okay. And there wasn't anything under it, so that's all, the entirety of our code right there. So the main reason you use the wrapper classes in this context is to get the parse functions. Integer.parseInt, float.parseFloat, Boolean.parseBoolean, that kind of thing. So if you have a string containing a number and you need to convert it, you can do so. I want to play a little bit and see if it can convert a hexadecimal to a string. So down here at the bottom, I'm going to put a hexadecimal number in there. I'm going to say number is equal to, like, 10AF. Right? That's a hexadecimal number.
A and F need to be capitalized.
Yeah. No, not necessarily. I think it'll work lowercase as well. So let's find out. Let's do int I is equal to integer dot parse int number, but I'm not doing base 10, I'm doing base 16. And now I'm going to print that out. System.out.println I. And so whatever 10AF is, I don't know. So I'm just going to change this to FF because I know that FF is equal to 255 in my head. Or maybe I'll make it FFFF because I happen to know that that's 65,535. All right, so that worked. What if we had to go the other way? What if we had a number and we wanted to convert it to a string, right? So I have I, and I'm going to set it equal to 256, and I'm curious about what the string representation of that as hexadecimal. Well, I should be able to call .toString on it. And maybe I can specify some parameter that'll convert it to a hex. I'm not totally sure about this. But let's try it. Number equals, I don't have a variable of type integer. You see, instead I just created it as a lowercase I. Okay, so I'm going to create a wrapper for it. Integer I equals new integer parentheses lowercase I, like that. And then my number string is equal to I dot to string. Nope, that didn't convert it. I could use string.format to convert it if I had to. That's one way to do it. That's a way to convert a number to a string so that you could write it out to a file or something like that. But it's not letting me convert it as a hexadecimal number. So this is just boring old base 10. Let's get base 16 going on. Number is equal to string.format, parentheses, quote, %x, end quote, comma, II. %x means hexadecimal. If I printed out %d, it would just do it as base 10. So I guess I'll put some comments. %x equals hex, %d equals base 10. So we see two different ways of converting something, converting a primitive data type. One is you can use a wrapper class, the other is you can just use string.format. I would just use string.format. But in order to parse data, you have to use a wrapper class. And again, the reason you do that is because if you write a graphical user interface application, then your data will come in as a string. And let's play with that. We're going to create a dumb little graphical user interface that all it does is it has an input field and it has a button. So, to do that, we are going to use Netbeans. So we're kind of veering off the map here. But I don't mind. Let's make a new project. But we're going to be very particular about what kind of project we make, I believe. New project. Why am I forgetting how to do this? Java application. Oh, I cannot believe I don't remember how to do this. Don't create the main class. So disable that and give it a cool name like lecture QGUI. The reason we're not making a main class is because when we create our GUI window, it's going to make the main class for us. All right, you see down here where I have lecture Q GUI under source packages? I'm going to close the rest of this stuff. It's confusing me. I'm going to leave that open because I'm going to copy it to our notes later. Anyways, projects, and here's my current project, right? Lecture Q GUI, source packages. I'm going to right click and do new. I'm not seeing the one that I want. Okay, JPanel or JFrame. Let's choose JFrame. A JFrame is a Java frame which will create a window that can be displayed on the screen. So I'm going to create, I right clicked on it, I chose new JFrame. What if you don't see JFrame? Well, you choose other and then you get a list of everything. Right, and you can type in JFrame up here. And you can see that it's under a library called Swing GUI Forms. There are other graphical libraries besides Swing, but Swing is the one that's built into Netbeans, so we're going to go ahead and use it. So I'm going to click Next. I'm going to keep the default class name, although I could call it Lecture Q GUI or something like that. I'm just going to keep the default class name, and I'm going to click Finish.
It says it's higher recommended that you do not place Java classes in the default package.
Right, we're not supposed to, but it doesn't matter, so I left it alone. Okay, so here's my little place where I can draw my graphical user interface. I can drag buttons out. I'm just going to have one button. I can drag an input field, which is called a text field.
Professor,
Yes, sir. Sorry.
Sorry, I got lost trying to find the thing.
Okay. So, what I've done, and I'm going to pause the recording, is after I got to my JFrame dialog editor, I dragged out a button from Swing Controls, and I dragged out text field from Swing Controls. I know. I'll be right there. So, you may have already noticed that if you double click on something, like if I click on J button 1, it goes into some code. What it actually does is it creates a button handler to handle that. Although I don't see that it did. It did. Here it is. That's okay. Eventually we're going to want to put some code in there, but if you want to get back to the drawing mode, you'll see design. You can toggle between design and source. And sometimes you'll create methods that you don't want. Like if I double click on this text field by accident, it has now created a method for that text field, so that if the user ever double clicked it, it would call this method. We don't have anything special that we want it to do if it calls that method. I would need to fix that. Fixing that, whoops, I need to go back to design mode. If I come on over here where it says properties, you see a whole bunch of different properties. You want to change the font of that text field, you can do that. You want to change the color of it, and you don't want that text field to be black, you could pick a different color for the text. If you want it to say something different, you don't want it to say text field, okay, that green is a very poor choice, huh? I'm going to make my text red. Alrighty. But what if I don't want it to say J text field? What if I want it to not have any input whatsoever, or maybe just the number 0? Well, that's one of the properties, right? Text. Right there. I could type a 0 in. There's also another way to get to that. And then, whoops, that shrunk my field down. Well, I don't like it being that small, so I'm going to go ahead and stretch it back out. So, I could also right-click it and say Edit Text, and it would let me do the same thing as coming down to the properties. Like 0.0, right? Whatever. Okay, and what am I going to make my button do? I want it to square that value. Every time they click it, I want that value to be multiplied by this by itself. So I feel like giving it a better text than J button 1, because the user's not going to know what J button 1 means. So I'm going to right click it, I'm going to edit text, and I'm going to call it square. Now remember I said I had a problem where I accidentally double-clicked the text field and created a method that corresponds to that? Well, I can fix that. Now it's not doing it. If you look over here, not only do you have properties, but you have events. And if you double-clicked it, then it would call that event, that method. I could just backspace over that and remove that method from my code. But I do want my button to call an event. So anyway, so I'm going to highlight the button. I'm going to double-click my button. Now it's not supposed to scroll down to the end of the code. It's supposed to scroll down to where the code for the button. So after I double-click it, it should have left me right here. JButton1 action performed. Why is it called JButton1? Because that's the name of the variable. I'm going to go back to the designer and show you. See, if I right-click on it and do change variable name, it's called JButton1. That's kind of a lame variable name. I could probably give it a better variable name, like square button or button square. I may just click cancel and leave it alone now. Okay, so I'm going to double click it once more time. Okay, this time it actually did take me to the right method. JButton1 action performed. To do, add your handling code here. Alrighty, so if I'm going to square that value, here's what I have to do. Get the text from the text field. Convert it to a double, parse, with parse double. Square that value. And then set the text of the text field with the new value. So every object on this screen, on the designer, is its own class. So like this text field here. I am going to give this thing a better name than what it's got right now, because it'll be easier for me to find later. So go back to your design page, design pane, toggle out of source, back to design. Right click on that and do change variable name. And where it says JTextField1, let's call it input text. I don't care whether you give it an uppercase T or a lowercase t. Input text. That way, I know what that variable is called rather than JText1. I might not be able to remember that. Okay, so I'm going to go back in to my source. I'm going to find my JButton action1 action performed. Let's get the text from the text field. Alrighty. String number equals, I'll help. String number equals this dot input text dot get text, parentheses in parentheses.
I just had a question.
Yes, sir.
So how come when you change the variable name, the name on the button itself doesn't change?
Because those are, yeah, the question is, we changed the variable name, why didn't it change the text itself? Because those are two different things. You don't want your button to have to be called square. And as a matter of fact, it's not called square. If I do change variable name, I'll see that it's called JButton1. What if I wanted to rename it to square button? Square button. I don't want that to change the text, right? Because this may be written right, you know, in Vietnamese or something. I don't necessarily want, you know, the text to change. Those are supposed to be two separate things. The text and the name of it are two separate things. Does that make sense? That kind of makes sense? I'm looking at you, Vincent.
Yeah, I'm good.
All right. All right. So this pulls the text out of that input text field. And you see why I typed this dot, because it made it real easy to find that variable. This dot, and as long as I remember part of the name, input, then it makes it real easy for me to find my field. But then I can't just set it equal to input text, because that's an object of type text field. Instead, I need to get the text out of it. So this dot input text, I know you've already got this, dot get text. Well, guess what? There's also a set text method. Just for funsies, let's do this dot input text dot set text quote ha ha ha. We're going to delete this, right? But when we press the button, it ought to take our text, and then it's going to erase it and replace it with the words ha ha ha. Not what we want, but just to prove that we can. Now notice the first time I run it, it doesn't know where the main method is, right? Because when I created the project, I didn't let it create a main class. Well, this JFrame has a main method, so when I run it, it asks me, what's your main class? Well, yeah, it's in this file. And there we go. So I click square and it replaces it with ha ha ha. And we're going to do something a little bit better than that. Okay, so we need to get that value. We need to parse it.
Something is not, this, the input text isn't recognized.
Yeah. So let me go ahead and type the next few things and then I'll do a wander about. We need to change that text into a number using parse double. We need to double it and then we need to call set text on it. Oh, when I was telling you about different ways of creating, converting numbers to text, there's like 3 ways really. You could do, here's the 2 most common, or there's the long way and there's the short way. X is equal to string dot format %d comma value. That'll turn it. Here's an easier way, or excuse me, convert it to a string. String is equal to empty quotes plus value. I like doing that just because it's a lot shorter, right? This concatenates the value of that variable to an empty string. Both of them are totally great. They both do exactly the same thing. This one's a little more cryptic, but you're going to see me use that real fast over here in my code. Okay, so we get the number, well, we get the string, now we need to convert it. Double D or D value or something like that is equal to double dot parse double, and then pass that string in, parentheses number, in parentheses semicolon. Now let's double that. D is equal to D times D. There's obviously other ways of squaring it, right? You could use math.pow, or you could use times equals. I need to create some output text so that I can call set text. So I'm going to type string S or string output text or something like that. Oh, I guess I already have a variable called number. I could just reuse that. Number equals empty quotes plus D. That's a fast way to convert it. I could also use number equals string dot format quote %f end quote comma D, right? They both do the same thing. Now I have it in a number, but I need to set the text, the visible text. I've done some calculations, but if I ran it right now, the square button wouldn't do anything, right? It's calculating it, but it's not displaying it. I need to set the text of the input text field. So my last line of code is going to be this dot input text dot set text parentheses number. And it's okay if you don't totally get this the very first time you see it, right? If you do get it, that's awesome. If not, we are going to hit this again. And certainly when you take advanced Java, as I hope all y'all do, then I know some of y'all are going to different colleges next semester and I will miss you. Let's run this to make sure it works and then I'll do walkabout. Okay, well 0 squared is 0. What do you know? How about 2 though? 4, 16, 256, 655. Okay, so it's working. Ooh, look, if I did it long enough, it got to infinity. We could do an if statement. We could convert it to the wrapper class and we could call isInfinity. And if it's infinity, we could reset it equal to 0 or something like that. Do we care enough to do that? Nah. All right, let's pause it. But where I lost most people is a couple of things. One is if you were a designer and you double-clicked on the text field, it created a method. and then some people put all their code inside that field. Input text action performed. But that's not where we wanted it. We wanted it inside a handler for the button. So we just had to go back to the designer, double click on the button and make a method for that. The other problem is I didn't make it real clear. I was creating a brand new project. So almost everybody added the J-frame to their existing project. Let me show you how I would have fixed it if I needed to fix that. I'm going to go back to my projects here. I'm going to reopen my old lecture queue, if I can find it. I'm going to add a J-frame to it. New J-frame form, whatever. And then I'm going to try to run it. And it doesn't do anything. It just does what it did before, which is print some numbers. The problem is that the properties are not set so that our new J-frame is the main class. So you go to Projects, you find your project, you right-click on it, you do Properties, and then you find the Run tab, Properties, Run, Main Class, you choose Browse, and you check your J-frame class as your main class. Then you're good to go. Then when you run it, it'll pop up the window. So normally when I do a lecture on the GUI editor, I just have a start fresh without a main class. Or the other thing that can happen is when you make a new project, it's real easy to forget to deselect that create main class thing. And so if you do that, if you make a new project and then you go and you add, well now I have way too many things open. Right, so then I go to my projects and I find whatever project that is right here and I add a J-frame to it, new J-frame. Great, I still have two things out in the project directory now. And so when I try to run it, it's not going to run the J-frame. Same thing. So I go, oh, well, I made a mistake. I created a .java file that I wasn't supposed to have. I could try deleting that, right? I'm going to be reckless and delete it. Hope that I'm not deleting the wrong thing, but I'm not sure that's going to fix it. Well, it asked me to check the main class. You can get to the point where it just flat out will not run. Not that it's running the wrong thing, but it flat will not run and it can't find the main class, and that's very frustrating. But go to Properties and set it. All right, I think we're about done for today. What was the whole point of that? I wanted you to see using the wrapper class. I wanted you to see, go back to Lecture Q GUI, how we use the wrapper class to get the value of a string. We pull the string out of that input text field, and then we use parse double to turn it into a number. Without this step, there wouldn't be any way to do any math. And then we converted it back to a string. There's more than one way to do that. I did it the way with the shortest syntax. And then we set. So this is an example of good object-oriented programming. Somebody has created all these classes for us, which makes it really easy to write a graphical user interface program. If we had to write this from scratch, it would take us forever. Okay. Lecture done.